Hi, my name is Tiffany, and I'm part of the education team at the Chesapeake Bay Foundation. Through a series of investigations and lessons, we've been learning about how water travels off various surfaces. And when we were studying the watershed model, one of the concepts we were picking up is that the land has changed drastically over the past 200 years. The watershed used to look very different, and we used to have a lot of these natural filters. We call them the big four filters. We had a lot more trees, a lot of wetlands, a lot of oysters, and a lot of underwater grasses. And those are what dominated our local environments. These were permeable surfaces, meaning that the water would soak down or percolate into the ground through this natural filtration process. Today, those natural filters have been replaced by a lot of impervious surfaces. Those are hard ground or hard land uses that don't allow that rainwater to soak in. And that's changed the way that the water flows over the land.
This schoolyard permeability investigation
is another one of the tools that are designed to get your students out on the schoolyard, asking questions, defining issues, identifying problems, and that is all part of the issue investigation piece of the environmental literacy model. And I know that going to your schoolyard to try these out, that might not be a reality. That might not, with COVID-19 protocols and safety guidelines in place and different people's individual comfort levels, maybe you won't do this. Maybe you won't head to your schoolyard or try to get permission to go to your schoolyard to do this. That's okay. This is another one of those investigations that can easily be adapted to do right at home. So I'm in my backyard. I could easily do it out front or in a nearby open space or a nearby park. We just want you to make sure you're doing whatever is the most comfortable for you.
Your task for this investigation is to answer the following testable and supporting question. Which surfaces are less permeable than others? You will explore, examine, collect data, and complete your permeability data chart.
So our first step is going to be to write a prediction, and we're going to support our prediction with one reason based on prior knowledge. Then we're going to write a hypothesis. That is a testable explanation, like an if-then statement. And you're going to base that on observation, experience, or scientific reasoning. Now let's talk about the materials that you'll need. So the very first piece of equipment you're going to need is a percolability testing instrument. Now these are really hard to find. You might have to do a pretty good search. No, I'm just kidding. All that means is a can. So I had pizza for dinner, took the can, one end popped off, the other end I took a can opener and opened, so I have a can. Coffee cans work as well. Or if you have PVC laying around, any pieces of PVC, a cylinder. You need a gallon jug of water. I don't have a gallon jug, but I do have a watering can. You'll need a stopwatch. Another item on our materials list is a graduated cylinder, and we're going to be measuring out 200 milliliters of water. Now, this might be an item that's back at school, not at home, and that is okay because this is something that I'm sure most of us have in our kitchens. Turns out 200 milliliters is right around 1 cup. So we can modify it and we can use 1 cup of water, and that will be our consistent variable at all of our sites.
So now we're going to go outside, and basically we're just going to conduct some perk tests, or do some perk testing or percolation testing. So you're going to choose 4 different sites outside, and then at each site you're going to take your can, and I'm going to make a line on my can, going around my can, so that is how far down in the ground I'll push the can, and so then I'll have this much of the can sticking up. And once I get my can set on the different designated sites, then I'll pour the water in and time it for 5 minutes. And then I'll make observations. How much of the water soaked down through the ground? Did any of the water soak down to the ground? Did it not soak down to the ground? And that's the information and the different results that I'm going to include in my data table.